Article 110.26 of the National Electrical Code addresses general requirements for grounding and bonding. When installing a fuse box outdoors on a rack, the minimum vertical clearance from ground level to the bottom of the fuse box is 9 feet. However, there are exceptions to this rule. Firstly, if the fuse box is enclosed within a locked enclosure, the minimum clearance is reduced to 7 feet. Secondly, if the fuse box is used to supply power to a permanent outdoor structure such as a pool pump or air conditioner, the minimum clearance is 6 feet. In addition to the vertical clearance requirements, several other factors should be considered during the installation process. Firstly, the fuse box should be installed in a location that is protected from the elements and physical damage. Exposure to rain, snow, and direct sunlight can deteriorate the fuse box components over time, leading to potential safety hazards and equipment failure. Providing adequate protection from the elements will help to extend the lifespan of the fuse box and ensure its reliable operation. Secondly, the fuse box should be within easy reach for inspection and maintenance. Regular inspections are essential to identify any signs of wear, corrosion, or damage that may compromise the functionality and safety of the fuse box. Easy access allows qualified personnel to perform these inspections efficiently and effectively, as well as carry out necessary maintenance tasks such as replacing fuses or tightening connections. Thirdly, the rack should be securely mounted and capable of supporting the weight of the fuse box. The rack serves as the primary support structure for the fuse box, and it must be strong enough to withstand the combined weight of the fuse box and any additional equipment or components that may be installed within it. Proper mounting technique should be employed to ensure that the rack is securely anchored to a stable foundation, preventing it from tipping over or collapsing under load. It is important to check local building codes and electrical permits for any additional requirements or variations. Local regulations may impose stricter standards or specific guidelines that must be followed in addition to the NEC requirements. Consulting with local authorities and obtaining the necessary permits will help to ensure that the installation complies with all applicable regulations and safety standards. Always consult a qualified electrician for proper installation and compliance with safety regulations. Electrical work can be dangerous if not performed correctly, and it is essential to have a qualified professional handle the installation of the fuse box to ensure that it is done safely and in accordance with all applicable codes and regulations. A qualified electrician will have the knowledge, skills, and experience necessary to perform the installation correctly and address any potential issues or concerns that may arise. This narration serves as a general guide and does not substitute professional advice. Always prioritize safety and consult with qualified professionals for specific installations. The 9-foot clearance is a general requirement to ensure safety and prevent accidental contact with live electrical components. This height helps to keep the fuse box out of reach of unauthorized individuals, children, and animals, reducing the risk of electric shock or other injuries. The exception for locked enclosures allows for a reduced clearance of 7 feet because the enclosure provides an additional layer of protection against accidental contact. The locked enclosure prevents unauthorized access to the fuse box, further minimizing the risk of tampering or accidental contact with live components. The exception for permanent outdoor structures, such as pool pumps or air conditioners, allows for a reduced clearance of 6 feet because these structures typically have dedicated electrical circuits and are often located in areas with limited space. The reduced clearance allows for more flexibility in locating the fuse box while still maintaining a reasonable level of safety. When selecting a location for the fuse box, consider the surrounding environment and potential hazards. Avoid areas that are prone to flooding, excessive moisture, or exposure to corrosive chemicals. These conditions can damage the fuse box components and compromise their functionality and safety. Ensure that the fuse box is installed in a well-ventilated area to prevent overheating. Overheating can cause the fuse box components to fail prematurely and may also pose a fire hazard. Proper ventilation helps to dissipate heat and maintain the fuse box within its safe operating temperature range. Use appropriate wiring methods and materials for the outdoor environment. Outdoor wiring must be protected from the elements and physical damage. Use weatherproof conduit, connectors, and enclosures to prevent moisture from entering the electrical system and causing corrosion or short circuits. Ensure that all wiring connections are tight and secured to prevent loose connections, which can cause overheating and arcing. Label the fuse box clearly to identify the circuits that it controls. Clear labeling helps to facilitate troubleshooting and maintenance by allowing electricians to quickly identify the correct circuits. Use permanent markers or labels that are resistant to fading and withering to ensure that the labels remain legible over time. Install a grounding electrode system to provide a path for fault current to return to the source. A grounding electrode system helps to protect against electric shock by providing a low impedance path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. The grounding electrode system should be installed in accordance with the NEC and local codes. Test the fuse box after installation to ensure that it is functioning properly. Use a multimeter or other testing equipment to verify that the voltage, current, and grounding are within acceptable limits. Check the operation of the circuit breakers and fuses to ensure that they are functioning correctly. Document the installation thoroughly, including the location of the fuse box, the wiring diagrams, and the test results. Proper documentation helps to facilitate future maintenance and troubleshooting by providing a record of the installation details. Keep the documentation in a safe and accessible location. Regularly inspect the fuse box for signs of wear, corrosion, or damage. Look for cracks, rust, or other signs of deterioration that may compromise the functionality and safety of the fuse box. Check the wiring connections for looseness or corrosion. Replace any damaged or worn components promptly. Keep the area around the fuse box clear of obstructions. Do not store flammable materials or other items near the fuse box. Clear access to the fuse box is essential for safety and maintenance. Schedule regular maintenance inspections by a qualified electrician. A qualified electrician can identify potential problems before they become major issues and perform necessary repairs or replacements. Regular maintenance inspections can help to extend the lifespan of the fuse box and ensure its safe and reliable operation. The NEC provides specific requirements for the types of enclosures that are suitable for outdoor use. Enclosures must be rated for the environment in which they are installed, taking into account factors such as weather, moisture, and corrosion. The NEC also specifies the types of wiring methods that are permitted for outdoor installations. Wiring methods must be suitable for the environment and provide adequate protection against physical damage and the elements. The NEC requires that all electrical equipment be properly grounded to protect against electric shock. Grounding provides a path for fault current to return to the source, tripping the circuit breaker and energizing the circuit. The NEC specifies the size and type of grounding conductors that are required for different types of equipment. The NEC provides requirements for overcurrent protection to protect against overloading and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The NEC specifies the size and type of overcurrent protection devices that are required for different types of circuits. The NEC requires that all electrical work be performed in a safe and workmanlike manner. Electrical work must be performed by qualified individuals who are familiar with the NEC and local codes. Safety precautions must be taken to protect against electric shock and other hazards. The NEC is a complex and comprehensive document, and it is essential to consult the NEC and local codes for specific requirements. A qualified electrician can provide guidance on the proper installation and maintenance of electrical equipment. Always prioritize safety when working with electricity. Electricity can be dangerous, and it is essential to take precautions to protect against electric shock and other hazards. If you are not qualified to perform electrical work, hire a qualified electrician. The 9-foot height requirement is not arbitrary. This is based on decades of electrical safety precedents and is still relevant today. This height is for ensuring incidental contact does not occur, or if children are playing, they cannot easily access the potential danger. This also gives more protection from animals as well. There are a variety of fuse boxes, panels, disconnects and so forth that can be installed in place of a fuse box depending on the requirement. Be sure to check the available short circuit current and interrupting rating of the equipment being installed. Also be sure to perform all relevant calculations of the feeder and branch circuit conductors as the NEC requires, because wire size must be appropriate for the amount of load being served. The ampacity of the wire should not be exceeded, or else the wire can overheat, melting the insulation and causing a fire. The main purpose of the fuse or breaker is to protect the wire so it does not cause a fire. The NEC minimum size requirements are present for a reason, because following them helps keep the installation safe. While you can always increase the size of the wire, you cannot decrease it below what the NEC says as a minimum. Furthermore, be sure to use appropriately rated wire nuts and electrical tape when splicing wires together. Loose electrical connections can cause fires, so be sure that these wire nuts are on there very tight. There are torque requirements from the manufacturer that these connections must adhere to. The enclosure that the fuse box is in should have an appropriate NEMA rating. For example, NEMA 3R is common for outdoor applications. The NEMA rating ensures that the enclosure is watertight and is safe to install in an outdoor environment. There are high NEMA ratings such as NEMA 4 and NEMA 4X that provide even more protection. Also be sure to install a bonding bushing when bringing the conduit into the enclosure so that the ground is properly bonded to the enclosure. There are a variety of acceptable methods to bring the ground to the metal enclosure. If using PVC conduit, it is especially important to run a grounding wire inside the conduit.